Welcome to the content of discrete computational structures, or in other words, discrete math. In this video, I'm going to solve the question about straight statements as known as true and false, and we will learn some basic signs such as uh, not, or, and. So let's see one example. The question: proof or disproof whether not. Okay, not parenthesis P or not Q, or parenthesis not Q and not P, and P itself are equivalent. So let's write our solution for that. So first of all, we have to construct the truth table with our variables, which is P first, Q, not P, not Q. Let's take this expression, P or not Q, and have to take this whole expression in not, and then this expression separately as well. And let's imagine that, or let's assume our expression is just one variable as x. All right. First of all, let's integrate statements for P, which is T, true, false, false, for Q, true, false, true, false. For not P, it's vice versa, which is F, F, T, T. For not Q, also F, T, F, T. For this expression, let's think. So we are taking P and then or P or not Q. So what gives us T and F? T or F? T or F gives us T because um, when we have or, we can take one of them. If there is one true, at least the output is going to be true. When we have T and T together, yeah, it's always true. Uh, when we have in both cases F and F, the output is going to be F. Uh, when there is at least one T, one true, it's going to be true. But since in here we have this expression in not, so we will receive uh, opposite output, which is F, F, true, F. What about this one? We have not Q and not P. We consider those two columns, so we'll receive. So when we have two false in AND notation, it will give us F. When we have true and false, the output is going to be false because when we have AND notation, in order to get true statements, there is a one mandatory requirement that we have to have both true. So F again. In here, it's also F, but in the last row, true. Okay, what about our whole expression? So we are taking those this column and this column and or column. Okay, okay. So we will receive F, F, true, and true. No, we cannot say that our whole expression is equivalent to P because in here it's T, it's F, this one is T, this one is F, this one is F, this one is T, and this one is F. So this one is also T. So uh, not equivalent. Thank you for attention.